So in fact, if I have to just talk about the IIT main structure, so only the composite function is left, which we'll be doing later. So don't worry about it. So, but pay attention to today's class. Okay, now let us start with the definition of function. What do you mean by a function? So you must have seen that in books, when you try and solve, something of this sort is written: if a goes to b. So this means there is a function from, how do you pronounce it, that there is a function from a to b, right? Or we can say there is a mapping which is mapping from a to b. This is how we actually say it in maths, right? So there is a function which says that elements in a, so how would you understand it? Elements in a are related to, they are related to elements in b, elements in b by some relation, by some constraint, by some constant. So this is how actually a relation works, right? So this is actually a basic definition. This is a layman definition of, you can say, layman definition of relation, right? So when does this particular entity becomes a function? So for example, if I have to talk about function is also a relation, but it is a subset of relation. All relations are not functions, but all functions are relation. That you must have to understand. So when does this particular constraint becomes a function? It says when b, so everything, so when you say there is a to b mapping is happening, so all the elements in this particular set will be called image of a, right? So you will say that a has images in b, and you will say, if you mark the arrow like this, you will say b has pre-images in a, right? This is how you actually just talk about how we say this thing. This is the syntax of saying, otherwise both actually mean same. So for example, if you say there is a set which contains a here, there is a number a 1, and you are mapping something like this, that a gives you 1 as the answer. So what I will say, image of a is 1, or I will say pre-image of 1 is a. So in this case you will call it as image, in this case you will call it as pre-image, right? Now let us see when this particular condition makes a relation a function. Let us try and understand. So for a relation to become a function, there has to be two unique conditions. Let me just talk about it. Okay, so let me just write it down. For a function which goes from a to b, when does this become a function? So for functions to exist, there has to be every element in a, right, in a has unique image, right? And the second very condition that we people have to try and apply here is that every element has, there should be no empty element, or I just write it as has image, right? It should have an image. Now let me just take it with the 4 examples that we people already have. So for example, if you see in this particular case, how many elements are there in a? So in this, 3 elements are there in a, right? So they are mapped as a. You just try and understand it as, if you input a, your answer will be p. If you input b, your answer will come out to be q, and your answer c, then you will answer me r, right? So every element in a, so 3 elements which belong to the set a, each has image. Yes, each has image, very true, first condition. And each has unique image, right? This is what you have to check actually. So each has unique image. So this criteria, both these criteria are being satisfied in the first diagram. So I would say this is a function. Don't worry, I am taking all the 4 to make sure that what do I mean by these 2 particular properties here. So for if I have to talk, there are, yes, 4 elements. There are 4 elements in this particular set. 4 elements belong to a. So each has image, right? Each has image. A will give you w as answer, b will give you x as answer, c gives y as answer, d gives y as answer. So each element of a has an image, irrespective whether c and d both give the same image. Don't worry about it. We are just talking about the elements of the set a. Then the second condition, has unique. It should have an image. In fact, it should has unique image. So check. So when I say about unique image, what do you mean by this? That A should not have more than one images. So A has one image, B has one image, C has one image, D has one image. Again, so that means this is a function. No problem at all. Right. So let us take the third diagram to differentiate the fact. So here again there are three elements. So here there are three elements. A has image L, B has image M, C has, in fact now AC has two images. So it has the first property, it has images, right? It is satisfying this criteria, but it is now not satisfying the uniqueness criteria. So ये uniqueness वाला criteria खत्म हो गया. Why? Because C has two images, right? If you are having two, so that means it does not have unique image. For unique, that means every element in set A should have only one image. So that means this is not a function. I can say this is not a function. Now let's talk about the fourth one. So fourth one says that A has image U, B is no image, C has. So if we talk about this, there are how many elements? Three elements, right? The first property that we used to check was that has image, right? So here there is a problem. Only two elements have image. Two elements have image. So this question is again over. So this is not a function. For function to exist, every element in the set A should have a image. So these two are not a function, whereas 1 and 2 are functions. So this is how you actually have to work out. Also keep in mind that the set A, so set A could not have empty elements, right? Whereas set B could have empty elements. That is not a problem. So if you see here in the second case, Z was empty. So here in B, if I talk about in B, there were four elements, right? There were four elements, out of which three have pre-images. So if I talk about with respect to B, I have to use word what? Not images, but we'll have to use word pre-image. So they have pre-image, right? So three have pre-images. So this is how this has to be taken. So B could have, empty elements, but A set cannot have empty elements. Okay. And if we go to the more generic definition of function, so layman definition of function says understand functions with the help of a machine. So function is a machine to me, right? It is a machine. Machine works as if it takes some input, right? And it returns some output, right? So there are three definitions that we have to study continuously in this particular chapter, that is domain, codomain, and range, or the image, right? Domain, codomain, range. So if we take this into this particular context, so image, the input is called domain. Machine is known as your function or the mapping. Any word will do, function or mapping. Output is known as range. So this is how you actually define a function. So function is a machine. Machine works only when it takes some input. So input is mathematically domain, and it will return some output, which is called range. So then what is codomain? Understand this. So that codomain is what may possibly come out of a function. May possibly, right? It is not that it will exactly come out, but what may possibly come out. But what actually comes out of a function or a machine is called the range. So for example, I have taken a function there. Mapping is done by every element in that you substitute here will be returning 2x plus 1. So for example, if you put 1, you will return 3. So see here how many elements are there in set B. So B has 10 elements, right? Out of which how many being are utilized? How many are serving as images? Only out of which 4 are images here. Clear? Only 4 are images here, right? What about 6? Remaining 6? So they are not taking, remaining 6 are not taking part anywhere in the image or the pre-image process. So what I'll say, if I have to talk about, so the range in this particular question, as I have highlighted, is only 3, 5, 7 and the 9 number. So if I have to talk about the range, I will write 3, 5, 7 and 9 as the range. Whereas if I have to talk about codomain, codomain is the entire set B. So understand it this way, codomain is actually set B. What all possible values it can take. So it is actually taking all the values from 1, 2, 3 to 10. So this is actually codomain, right? Which could be empty, as we just did in the earlier slide. Codomain can be empty, just see to it that domain should not be empty. Every element in domain should have a image in codomain, right? Let's start with the domain part. Okay, so these are some, first of all, before going to the other sections, we have to do some important functions which we have to remember. And I believe that you people already know this. I'm just taking it for the revision purposes, mind it. Right, so this lecture is basically on revision. I'm not going to teach you the entire functions again. So it says y equal to x, which we know is a linear function. It is just to make sure that you know the graph. So you have to remember the graph and you have to remember the domain. So domain is minus infinity to infinity, or you can say the all real numbers, right? So domain and range of a linear function is R, right? Then you have mod x, which is actually a V shape, right? Remember it as a V shape. It has domain as it, you can, for domain, that means what, so understand domain as all what values x can take. Domain is values which x can take, right? Values which x can take, right? So if you check here what values x can take, so that means x will lie on the, yes, on the number line, right? So for every number element on the number line, you have actually a value in terms of y, right? So that means it is taking all values of x. So that means domain is R, but it is returning you only what? Positive values and 0 at x equal to 0. So that is why we say range is, yes, 0 to infinity. You have to remember all these things, right? This is the basic quadratic that you draw, parabolic shape, right? Domain, again, you can take any value of x here, right? And the for range, we'll talk about only positive numbers and including 0 at x equal to 0. Under root, in case of under root, you cannot have a negative value inside the under root. So very important stuff, under root. So input of, so let's say if this is the input, right? So input of under root has to be, yes, greater than or equal to 0, right? It can never be negative. So that is why left hand side is not being drawn. You will never find anything on this particular side, right? Range, again, if you input positive numbers, you will get positive numbers. X cube is something like this. If you are not able to see it properly, so the graph could be drawn something like this, right? Okay, so this is the diagram of y equal to x cube. For x cube, there is no problem by putting x again, right? And you will get any value of y also. So both domain and range are R. So I'm going through a very rapid way because I want that you people just quickly remember this and learn all these stuffs, right? Okay. The next basic graphs that we people have to understand and learn is this is the exponential graphs. So this is the exponential graph, b raised to power x. So let's say b raised to power x, or you can say a raised to power x. That's not a problem. So it depends on what is the value of b. So first of all, remember that this is something of the sort base raised to power variable, right? So here base has to be positive. You cannot have a negative base here, right? So base has to be positive. So that means here b has to be greater than 0, whatever be the condition, whatever, right? So now we have two answers. If base is greater than 0 but is less than 1, right? So this is the case 1, right? So the diagram for this particular case will be something like this. This is the shape of exponential, where it will take only positive values. So here if I have to talk about domain, domain will be all real values, but the range of the function will only take what? 0 to infinity, positive values. Whereas if b is greater than 1, right? So the diagram of the same exponential function would be something like this. Okay, again the domain will be belonging to R, range will be again the same. Answers would remain same for both of them, but yes, you will get some different shapes of the curve as it's seen. So here the diagram is for b greater than 1. Other important graph that we have to remember is your log x as drawn here. So this is the shape of the log x graph when base is greater than 1. Again, if the base is less than 1, then you have a problem. Then the shape would be something like this. Okay, just you have to remember this, believe me. The domain of the log, so that means in log you cannot have an input which is negative. So log of a negative number is not defined, right? And it can return you any value. Okay, for inverse function, this is the graph. If you are not able to see clearly, let me just draw it for you on the same scale. So it is something of this sort, where these lines are acting as asymptotes, right? So this is how we have to draw the graph of y equal to 1 by x. This is how the shape is. Okay, domain is it, you cannot just put value 0 because denominator will become 0. Otherwise you can put any value, and in fact for y also you will get any answer except 0. You cannot get 0. For this y equal to 1 by x square, the shape is something like this. right? So it will return it. You cannot again put x equal to 0, but the range now would be only positive numbers, right? There is no, you can see that the graph is not in the lower portion, so you will not get any negative answer. Very important, the step function, right? So step function is like something that steps are taking. So this is the GIF function. You know that GIF is discontinuous at integer inputs. So you can put any value of x, but the answers that you will get will only be integers. That is very important in this particular case. We'll do all these, don't worry about them, right? I'm just revising it for you people. Another important stuff that you people have to remember is the trigonometric graphs, right? I hope that you people know all these stuffs. So you just have to remember that what are the domain and range of sine and cos. So sine and cos actually have the same stuff. They have domain as r and the range is -1 to 1, right? What about tan and cot, tan x and cot x? So tan x will not work at those values. Where? Can you tell me? So for example, if you want to remember, so tan x is nothing but sine x by cos x. So it will not work when this cos x becomes equal to 0. Can you tell me a value where cos x becomes 0? Quickly. So yes, it becomes 0 at pi by 2. So that means you want to remove all those values where you will get value pi by 2, that is odd values of pi by 2. So this will not work at this, and answer could be any, because we know that the graph of tan is something of this sort, right, where these are the asymptotes. So it can return you any answer. Similarly for Cortex, do it yourself. What you will say that for Cortex we have cos x by sin x. So whenever sin x is becoming 0, then you will have problem here. So it is minus n pi. Again it will take all values. I'm just going in a very rapid fire round because I believe that you should be able to do all this stuff. For secant x, what is secant x? Secant x is 1 by cos x. So whenever cos is having a problem, that is cos should not be equal to 0, the same answer as tan. That means the range, the domain of this is actually equal to the tan. And similarly I can say for the cosecant, the answer would be same for yes. Now you are getting hold of it. Okay, remember it something like this. For this, revert the answer of range of cos and sine. So for cos and sine, the range was -1 to 1. Reverted you, so you will get minus infinity to -1 union 1 to infinity. The same answer will be for cos. So you can see that there is an inverted graph here. See here, right? So that means it will take values which are less than -1 and which are greater than 1. Talking about the inverse, inverse is again very important that you people have to remember. So for inverse, how you can remember, I will give you a hint that for example, there you have to remember a sine family and the cos family, right? Okay, so if you want to talk about the domain is very simple. So let's see, this is the graph of sine inverse. The range of sine x becomes the, yes, domain of sine inverse. Range of cos x becomes domain of cos inverse. Domain of tan inverse becomes what is actually equal to range. So these are the graphs of tan inverse. This is tan inverse x. So what is the range of tan x? R. See, we just did the range of tan x is nothing but R. So it becomes here domain, right? So for domain, how you can understand, for domain of inverse functions, what you can actually do is domain of inverse functions are equal to range of normal trigonometric functions, respective trigonometric functions, right? Got it? Clear? So that is why they are important. Now if we were to talk about the range, what is the range, right? So don't understand it in a way that range of inverse will be then equal to range of inverse will be equal to domain. This is not valid. Don't do this something. This is not equal to domain of, that is not a concept, right? So how do we remember it? Is a sine family. So what are the members of sine family? Sine inverse, right? Then you have tan inverse, and then you have what? Cosecant inverse. Members of cos family include cos inverse, cot inverse, and members, third member is secant inverse. So range of sine family and cos family you can do only if you remember the first member, that is sine inverse and cos inverse. So what is the range of sine inverse is? Can you tell me? Minus pi by 2 to pi by 2. This is what you will have to remember. There is no shortcut for it, right? And for cos inverse, it lies from 0 to pi, both inclusive, right? If you remember these two values, I can give you a method for finding the remaining 4. So tan, what do you people have to do for tan? Just change the brackets. So they were square brackets include round brackets here. Similarly here, that's the answer for cot inverse. For cosec inverse, what you do? Write the answer that you have written for sine and remove the midpoint of this. So what is the midpoint or the average of this is 0. Similarly do this, include the answer as it is of cos inverse minus the midpoint. Midpoint would be pi by 2. So this is how you find actually the range of inverse functions. So this is how you can actually learn range of inverse functions, right? So I have given you a tool to remember how to memorize range of inverse. For domain there is nothing to be done. Range of normal trigonometric function, it becomes the domain of inverse functions. Got it? Okay, let's start the topic domain. For domain, what you people have to understand, let me just highlight the basics of domain first of all, right? Basics of domain. So for basics of domain, what do you understand by domain is values which x can take. Values which x can take, right? Which x can take in fx, right? If the function is in terms of fx, right? So what is the problem when you have to, so the short trick is that when the domain will be asked denominator, so if there is a denominator, then denominator should not be equal to 0. This is the first rule of mathematics. So you have to find those values of x where denominator becomes 0. Second problem will arrive in under root, right? If there is something under root, so this input under the inter root should be always greater than 0, right? And the third important step would be the log, right? If something log here is written input, right? So then this input has to be even greater than 0, right? And if this base is also given, so then the property for log is that base has to be greater than 0 and base should not be equal to 1. So these are the three conditions that you will check for domain of log. So this is how you work for domain in case of log quotients, right? In case of log, otherwise there is no problem. So if you can just remember these three basic rules of domain, we are done with it. Clear? Now let's apply them in the question and see how we work around. See, so it asking you, the questions are basically based on finding domain. So I have taken three questions. We'll go step by step. So the first question says 1 upon x plus modulus x. So first of all, understand how many functions are there. So I can understand here, first of all, there is a denominator because everything is written in denominator also, right? Denominator. So what is the condition? The denominator should not be equal to, what is the denominator? When does the denominator becomes equal to 0? That means if this becomes 0, right? So the denominator will become 0. You want this should not happen. So how do we solve not equal to 0? Then try and find out when this becomes 0. When is this 0? Can you tell me? Obviously, say so mod x. So for mod x, what you can people should think, some answers would be positive and some would be negative. That is plus x, or it will return you minus x, right? So it will return minus x when x is negative, and then only you will get answer 0. Or orally you can also do. So if you want to solve this particular stuff, so if x is negative, mod x is always positive, right? We know that mod x is always a positive quantity, always positive. So if this is negative, then only you will get 0. So the answer to this becomes when x belongs to negative number, right? So this will not work when x is a negative number, right? Then the other condition that you people have is under root. So under root says that everything which is inside it should be greater than 0, greater than equal to 0, right? So input is what? X plus modulus x should be greater than or equal to 0. But in fact, if you club this, denominator should not be 0. So if I club this becomes x plus mod x should be greater than 0. So this is the biggest condition that we can apply in this question. Can you tell me what will be the answer to this then? Yes, very simple. So that the answer to this particular thing would be that x should belong to positive numbers. Then only this will be positive, right? It should take positive numbers only, because if you put a negative number, though the answer will not come out to be negative. For example, if you are confused about how these questions are working, just take an example. So for example, if I pick x is equal to, let's say, minus 5.3, Let's try with this. If you put minus 5.3, this becomes minus 5.3 plus 5.3, which gives you answer 0. We cannot have a denominator 0. So the only answer that we are going to write is x should be greater than 0. So this is the answer to this particular problem, right? This is the domain of this. Let's apply this in the other problem. It says fx is equal to x square minus, so this is now GIF, right? Now understand GIF also. It says x square minus GIF of x square. Okay, so again let's see what is x square. X square is again always positive, and you are given under root. So this function is basically an under root function. So we understand about under root is that input should be, so this is the input, so this input should be greater than or equal to 0. Now this time around it could be equal to 0 also, because it does not have any denominator, right? So that means you want to check when is x square greater than or equal to its GIF component ka square, right? So also remember that this square is not inside, it is outside the GIF, very important. Okay, so it is something of this sort that you are checking x square is greater than, first we will take the GIF and then we will take the square. Okay, now when this thing will happen, for example, again we'll take numbers 5.1. So which one will be the greater quantity? For LHS it will become what, 5.1 square, but this will be only what, 5 square, because 5.1 ka square GIF kya hoga, 5. The GIF of 5.1 will be 5, so that means 5.1 is acceptable in this answer. Now let's take minus 5.1. So this will become what, minus 5.1 square, but for the RHS, what is the GIF of minus 5.1? Can you people tell me? So yes, the GIF of minus 5.1 is not minus 5, it is actually minus 6. Please revise this, this is very important. So this will become minus 6 square. Now this time round this will become greater, so that means this will not satisfy, right? This answer will not be satisfied. So minus 5.1 is not in the answer. Now let us check also, let's take for x is equal to minus 5 only. What is the answer then? So the LHS then becomes what, minus 5 square. This works very well, so this gives you answer 25. What happens when RHS is there? So RHS is GIF of minus 5 square, which is also again 25, right? And you wanted what, greater than or equal to 0. That means they could be equal also. These two are equal. So is this a part of answer? Yes, this is also a part of answer now. So this is included, this will have to be included in the answer, included in answer, right? So what will be the answer then completely? We have answers satisfied by, first of all the positive numbers are satisfying, all positive numbers are satisfying, whether they are integers or they are mixed fractions, they are all satisfying. For example, we have checked for 5.1, 5 will also satisfy because both of them will become 0. What about negative numbers? We are getting negative numbers, negative, but they should be, yes, they should be fractions. No, fractions are not getting satisfied. The fractions is not, in fact negative integers are satisfying your answer. So what we will write as the net answer for this will be x belongs to R positive union Z negative. So R positive is meaning all the positive numbers, union of all negative integers, union 0. So if I write R positive, that means I have not included 0. So this is the particular answer I am looking for. This is the answer to this particular question, right? So if you're not comfortable with that one, you just have to revise it again and again, right? Let's take the third one. So third one says 2 raised to power sine inverse x plus 1 by x minus 2, right? So 2 raised to power sine inverse x, so the function fx. So for these kind of mixed questions, just figure out where you are finding x. So there is x here, right, which is in terms of inverse function. So what is the domain of sine inverse? This function will work when x belongs to, yes, minus 1 to 1, right? That is why I did a 10 minutes topic earlier, to just to make sure that you people again revise what is the domain of sine inverse x, right? And then the other function that you people have is this. So for this to work, there are two conditions. First of all, there is denominator also. So denominator should not be equal to 0, which is happening at 2. So x should not take 2, and then there is a under root function, right? There are two functions. So for under root, it should be x minus 2 should be greater than 0, not equal to, because it is denominator. So that means x should be greater than 2. So if there is a plus in between, how you people should understand is there are two machines. So there is a function 1 which is working as a machine 1, and there is a machine 2, right? Machine 2. So both of them should work to get the final answer, right? Then only the machine will work. Machine, let's say something like this, machine answers only when both work, right? Something of this diagram is there when both work. Even if any one of them was not working, then we have a problem. So we want to find an answer on which we find an answer. So what I mean is find an answer for which both works, right? So it says the first machine will work when x belongs to -1 to 1. Here it says that the second machine will work when x is greater than 2. There is a problem. Can you find a common answer? No common answer. So that means the domain of this function is null set. You will not find any particular answer which will be satisfied by this particular problem. Okay, now let's take the other problem, which is we have to find domain of this. Again, it is 1 upon under root this. So that means this under root quantity should be greater than or equal to 0. Wrong. Yes, it should be only greater than 0 because denominator cannot take value 0. And now these are all GIFs. So for the time being, you just assume that this is nothing but t is equal to GIF x. So this becomes t square minus t minus 6 greater than 0, or you can say t minus 3 into t plus 2 greater than 0, right? And if you draw them on the number line, so this will be something of this sort, plus minus plus wavy curve. This is the wavy curve that I am following, right? So this is how you draw, and this says that t should take values belonging from minus infinity to minus 2 union 3 to infinity. But you were not asked the value of t, you were asked the value of, so this is GIF x answer, right? And domain is not what values GIF x can take, domain is what values x can take. So you now need to convert this into what values x can take. And now this could be a bit tricky one. Now let me help you in figuring out how we solve this particular question. So it says that GIF x can take values minus infinity to minus 2. Let's break it in two parts. So what is the biggest integer that it can take? Biggest integer, mind it. So minus 2 is an integer, right? It is the biggest integer in this set because the smaller the negative number, higher it is. So the biggest number is minus 2, but it is not included here. So the minimum value could be minus infinity, but the maximum integer that this will take is minus 3. And when you will get an answer minus 3, can you tell me? If I just plainly ask you GIF x is equal to minus 3, when you will get this answer? The answer to this problem is when GIF is either minus 3 to minus 2. This is the answer to this. So for example, if I have to say that x is equal to minus 2.7, then the GIF of this will be, yes, minus 3, a 1 less than the number. So the 1 less integer would be minus 3, not minus 2. So just remember, the answer to this particular problem is not equal to minus 2. Don't do this error. So if I say I have to pick a number minus 3, then my range could vary from, that means for this to be happening, I can take the values of x moving till minus 2, not including minus 2, because at minus 2 the function will become minus 2 itself. But if this is the answer, then the largest integer that it will take will be minus 3, and my condition is satisfied. So this becomes minus infinity to minus 2 only, right? But do not include minus 2. Why I'm writing it is because if you even pick minus 2.7, right? So this value will be what? Minus 2 only, minus 3 only. Now let us take it for the positive side. It says GIF x belongs to 3 to infinity, right? So how do you solve it? Let's see again. What is the biggest integer it will satisfy? Or smallest integer this time round. It will start from 4, right? So that means if I have to write something like this, so the integer values that it will take is 4, 5, 6 and so on, right? But it will not take value 3 because GIF X is not including 3 here, right? When will you get 4? Can you tell me when will you get 4? When will you get GIF X is equal to 4? Can you get a integer value 4 when X is less than 4? You will only get this answer when you started from 4 to 5. Very important step again, right? So you wanted that the integer part of the number should be lying from 3 to infinity where it is not equal to 3. So that means it should start from 4, right? So it is trying to say that the integer part of the number should start from 4. So what should be the value of the input then? Yes, so then the input should also start from 4. So this is the answer we were looking for in this question. It's a very tricky problem. You need to revise and see the video again to understand this concept. Okay. Now let us take the next problem, which says that we need to find the domain of this particular function. So let me write the function again for you people. It says, so whenever you start writing, then only you should start understanding what is being asked. So first of all, you will draw under root. So that means whatever is inside it has to be positive. Then there is log. So we also understand from the log that whatever is there has to be positive inside the log. And then we understand there is a denominator also, so then denominator should not be equal to 0. So I can see there are 3 functions, right? And then we'll go in the reverse order. Let's say there is first of all denominator. So for denominator should not be equal to 0. So here denominator is Sine X, so Sine X should not be equal to 0. This happens when? That means Sine X should not be equal to n pi, where n belongs to integers, right? जब n integer होगा, so then you will have problem over here. Second is the log. Log says, so input should be positive. Input should be positive. What is the input here? Can you tell me what is the input? So input for log is 1 by mod Sine X. So what do you mean by a modulus function? Can you tell me that this function is always positive, right? So that means the condition of log is also satisfied, nothing. So it will work for every value of x belonging to R minus this particular answer, right? The 1, I can just write it 1. Let's say this is 1, right? Let's take the third part then. Now you have to solve for under root. So for under root, what it says that input again should be, under root will work when input is positive. So input is log 1 upon this. So this should be positive or 0, right? Or 0. So how do you solve this? This is the important part of this question. So now let us try and understand with the help of a diagram of log. So this is the diagram of log x, right? Log x to the base b when base b is greater than 1. If here nothing is given, right? So that means we assume that base is equal to 10. So this is the diagram of log that we will be using, right? Okay, otherwise the diagram of log when base is between 0 and 1 is this, right? Otherwise you will have used this if base is between 0 and 1, but this is not the case. Okay, so what will happen now? Let's see. So log, if you can see, is you want that this particular value of the log should be positive. So log is positive in this particular range. You want the output of the log to be positive, not the input, right? Input is always positive, we know that. So this is positive when you should also remember that this is x equal to 1. Why? Because log 1 is equal to 0. So that means this point of intersection is what? 1. So that means if the input is greater than 1, then log will also be greater than 0. Please remember this is very important. So log will return you negative answer. See, you can see here log is negative in this particular region. So for log to return negative values, the input should, you can in fact remember this is a result also. So log x is less than 0. So for this x should be between 0 and 1. If this is greater than 0, then x should be greater than 1. And at x equal to 1, log is 0. And I'm taking this when b is, all these results are when base is greater than 1, right? This particular diagram. For this particular diagram, the answer would be reversed. Now we have here 1 upon, the input of the log is 1 upon modulus Sine X, right? Okay. Can you tell me what are the ranges of Sine X? Sine X takes values ranging from minus 1 to 1. So for modulus sin x, what are the values? They will become from 0 to 1, all positive values. What will be the value which will take 1 upon reciprocal? Remember reciprocal. So for reciprocal, this will become 1 to infinity. That's the answer. Just imagine if there is a number between 0 to 1 and you take reciprocal, 1 upon a fraction will be greater than 1, right? So that means the input of the log machine. So log already has an input here which is 1 to infinity, right? So 1 to infinity, that means either it will take 0 or it will be greater than 0. So that means this has no problem. It will work for every value of r. So if you try and match all the three conditions, it says I will work for every value of r, no problems, right? Except again denominator wala condition hata do, except 1. It also says second condition, x belongs to r except 1, and we have already find what is the exception. So the answer to this particular problem is x belongs to r minus n pi. This is the answer. So at the front this looks like to be a very indominating problem, right? But it is a very simple problem. If you know all this concept, this question is actually oral. It will hardly take you 10 seconds, believe me. People who are very comfortable in functions will be able to solve this orally, maybe within under 5 seconds. Okay. Okay, now let's take another two problems on domain. It says, the first question says quickly, let's start it quickly. So it says sine inverse of this. So we have outermost function as sine inverse. So the condition of sine inverse has to be applied. So before even going forward, I can immediately think of that whatever the question is, this must lie between minus 1 to 1, right? This has to be first of all satisfied. Okay, how do you do this particular condition now? Can you tell me how you people will solve this? Yes, so I have drawn the diagram of log for you people. So you people want actually that log will be from minus 1 to 1, and the base of the log is equal to 3. So how do you solve it? How do you actually solve log is something of this sort. So what you people will do is 3 raised to power minus 1, log hat gaya, right? You can just remove the log component. So for removing log, you will take 3 raised to power minus 1 x by 3 less than equal to 3 raised to power 1. This is how you people will have to solve, because we know that log 3 is 1 and log raised to power 3 minus 1 will be minus 1. Now you can just cross multiply and this will become 1 less than equal to 9. So this is the answer we are looking for. So if x lies between 1 to 9, then the sine inverse machine will definitely work for you. Now coming to the log part also. Now let's see the log part. Now this is not the correct answer. So if you people have answered this, it might be wrong. So this is the first step. What we have done is, and we have identified sine inverse. Now log machine is also there, right? So for log machine to work, what is the input of log here? So the input of log machine here is x by 3. So for log to work, this should be greater than 0, or you can say x should be greater than 0. So log machine will work when x is greater than 0. Sine inverse machine is working when x lies between 1 to 9. So the net answer of taking intersection of these two will be x belongs to 1 to 9. Now you can confidently say that this is the answer, because for this the log machine will work, not a problem. Okay, this is how you solve these kind of questions. Again, a very simple one. Another question based on log, the second problem is question 2. Let's say, so this is again a very basic problem. It says you want to find the domain of this. How many log machines are there? One log machine, second log machine, the third log machine, right? Clear? So let us start from the innermost. So for this, x has to be positive first of all, right? For x it has to be a positive, right? Now if I start from the second machine, I'll also tell you a short trick for this. So the machine 2 will be log 3 into log 4, like this. For this machine to work, the input of this machine, that is this, should be positive. And if you solve this, this becomes x raised to power x greater than 4 raised to power 0, and this says x greater than 1. So this is machine 2, M2, right? This is the third machine, M3. So M3 is log with base 2, log with base 3, log with base 4x. So the input for machine 3 is this particular value, which again should be greater than 0. So for machine 3 to work, this is the input. This should be greater than 0. And how you solve it? In the same process. Don't worry about whether there are 2 logs or 3 logs or 50 logs. So you will say 3 raised to power 0. this becomes what? Log x raised to power 4 should be greater than 1. 3 raised to power 0 is 1, and this will become x greater than 4 only. So this implies x greater than 4. So now you have all the answers for all the three machines. It says I'll work, machine 3 will work when x is greater than 4. This says when I'll work when x is greater than 1. The third machine says when I'll work when x is greater than 0. All the three machines will work when, yes, answer is x greater than 4. That's it. And for these kind of problems, you need not solve these two machines. Don't waste your time. So just solve the first outermost machine. If you see properly, all these answers are already included here. So you need not have to work about. So just solve the outermost machine. Just solve the outermost machine in this case. That's it. Right? This is how you actually try and solve these kind of questions. Now let us start the range. So we already did that. Range is the values of the machine. Range is nothing but your output, right? Now there is something very important. Output when input is defined. When input is defined. So this is what you people actually have to remember. This is very important, right? Very important condition. So let me highlight this by taking this particular question as question 1, right? So you are asked to find the range of this particular function, right? And what generally we people do error in this is that we are very happy, oh, this is a very easy problem, and we just write it as fx is equal to x plus 3. Now this becomes a linear function. Linear function, we know that the range, it could be xr, right? It will take any value of x. For you put x, you just add 3. That means you can actually, this machine will take every value. It will give you every value of on the number line. But the problem is this is not the answer. What is the problem is, so whenever you are asked a range problem, right, whatever might be the step 1 of the range problem should be to find domain. Whatever might be, the first step should be the domain. So if I ask you the domain of this particular problem, the domain is x should not be 3, or you can say x is r minus 3. Right? In fact, in mathematics, you can write this from this only when you have written this condition that x should not be equal to 3. Because otherwise you are cancelling 0 by 0 and you are writing it equal to be 1. Very absurd. आपने यहाँ से यहाँ लिखने में क्या कर दिया? 0 by 0 को 1 कर दिया. This is what you people have done, which is completely absurd. Now you understand? So the domain is that it says x belongs to r minus 3. Now you have the function that fx is equal to x plus 3. So now if you apply this here, so the answer would be that fx will take all values except the value when x is equal to 3. So what will be the value when x is equal to 3? 6. Yes. So the range of this particular function will be all values of r, or all values except that value when x is equal to 3, which is 6. So this is the correct answer to this particular problem. Remember, though it looks like a very simple problem, but yes, many people do this error. So range is equal to output when input is defined, or at what particular values you are solving it. Now let's apply this into another basic problem. It says that you need to find the range of this particular function 5 plus sine x plus cos x. So this is a trigonometric problem, and again a very standard problem, right? You need to remember this, how we are solving this. So 5 is a constant. The only variable part is with sine x plus cos x. So it is something very much similar to, if I try and make it short, it is something of this sort. Now some people would have actually got this. How do you solve this? Finding maximum and minimum value of this. Remember, we did it in trigonometry, basic trigonometry. What you people will have to do is you have to multiply and divide this by what? Under root a square and b square. This is under root a square plus b square. And if I split this, writing like this, a plus a square sine x plus b upon under root a square plus b square cos x, right? And this is already, I have to write it here, right? So I can take that for some cos theta, this will become a by under root a square plus b square, and similarly for some sine theta, then it will become b by You can very well easily check. Just add square and add, you will get 1. That means my assumption is true. So then this complete quantity will become what? Cos theta sine x plus sine theta cos x into under root a square plus b square. Okay. And what is this formula then? Yes, so this formula actually reduces to what? This becomes sine of x plus theta into under root a square plus b square, right? And what is the maximum and minimum value of this then? So we know that sine for any value will be between -1 to 1. So this will actually take values lying between minus under root a square plus b square to under root a square plus b square. And this is what you people have to now remember. So for a sin x plus b cos x, this is the range. Please remember, this is completely very important, right? This is the range. So now your role of a and b in this particular question, if we talk about our question, here a is 1, b is also 1. So the range will be from minus root 2 to root 2 of sin x plus cos x, and you are adding 5 to this, right? You are adding 5 here. So add 5 on both sides. So the answer will become 5 minus root 2 goes till 5 plus root 2. This is the answer we are looking for. This is the answer. That's it. This is how you solve these kind of questions. Very important. Okay, now let's take another 3 problems. It says you want to find the range of all these 3. So let's start with question 1 first. So it says 1 upon 2 minus sine 3x. What is the range of sine 3x? Now let me ask this to you. Don't worry about this 3 does not have any role in the amplitude, right? So this is nothing but will still remain from -1 to 1. Very simply. Had it been 3 sine x, then it range would have been from -3 to 3 only. Now since it is sine 3x, so do not worry about it. So for example, if I have to convert this into formula, a sine bx will have its range from -a to a. Got it? So now coming back to our question, it is only having what? Sine 3x, right? So sine 3x will, that means lie from -1 to 1, right? And you have minus sine 3x. So for minus sine 3x, it will be what? Again from -1 to 1, right? So if you want to learn the property that what I have done here, so the formula of inequality that I have used is if x lies between a to b, then minus x will lie from minus b to minus a, right? This is what you should actually remember. Again, formula for you people, new formula, right? But if you see here, because a and b are having same magnitude, so you were not able to figure out what I have done. Okay, so now moving forward, the problem then becomes you have got minus sine 3x values. Now you want to add 2 here. So 2 minus sine 3x will become what? Add 2 on both sides, it will become 1, and this will become 3. But this is your denominator, you want the reciprocal. So what will be the value of 1 upon 2 minus sine 3x then? Then the answer would be less than equal to 1 by 3, less than equal to 1. So now again what I have done, again a formula. So if x lies between a to b, right, then what will be the value of 1 by x? 1 by x will lie from 1 by b to 1 by a. Take the reciprocal, put it here, take the reciprocal, put it here. So that is why 3 comes here and 1 goes here. So the range of this particular problem is from 1 by 3 to 1 by 1 only. Got it? Okay, now let's take the other problem then. The other problem says that we need to find the range of this. It is a logarithmic function now. Log with base 5, 25 minus x square. Okay, so people who have understood what is log, first of all, if you know the diagram of log, it becomes very easy problem. This is the log diagram of log, right? And since we have done increasing and decreasing, so this is an increasing graph. Y increasing, as the values of x increases, the value of y also increases. So the larger the value of the input, larger will be the answer. So the largest value of 25 minus x square, can you tell me what is the largest value? So the maximum value of this could be 25 at x equal to 0, and at this particular value you will get your max answer, right? So if you solve this, becomes log 25 with base 5, so that answer would be 2. That means the maximum answer to this particular problem would be 2. You need to find now the minimum value, right? So for minimum value you need minimum input, but keep in mind that log only works when x is greater than 0, right? So if I talk about the minimum value, what could be the minimum value near to the 0 mark? So if you take, for example, x is equal to 4.99, right? So what will be the x square? It will almost be equal to 25, but will be something less than 25. So this 25 minus x square will be almost 0, but will not be exactly 0. I can say almost like 0.00001, something of this sort. And if this small value is being inputted in x for log, can you see where the graph is moving? Graph is moving downwards. So the least value that it can take is minus infinity. So the range of this particular answer will be then minus infinity to 2, where 2 will have close bracket. Okay, let's solve the third one now. So third one says that you have a tan function, right? And again, if we want to understand how does a tan function work, draw the diagram of tan, right? So this is the diagram of tan function, which again very interestingly is an increasing function. For increasing, again, as you are increasing the value of x, right, the value of y is, you can see, is also increasing, right? So the lowermost value of x input will give you the lowest value, highest value of the input will give you the highest value. So your target is, your input is now pi square by 9 minus x square under root, right? This is the input that you people have given to this tan machine. What is the minimum value of this? Can you tell me minimum input? Minimum value of the input? Yes, minimum value of the input is 0 when at x you put what? Pi by 3, right? Clear? What is the maximum value then? Yes, very good. So for maximum value, you are subtracting something from a fixed quantity. What is the fixed quantity? It is pi square by 9. Just put x equal to 0. That means you are not subtracting anything. That will be the maximum value. So the maximum value will be what? Under root of pi square by 9, which is pi by 3 at what value? At x equal to 0. So the minimum value is 0. Maximum value is, so the range will be, yes, now you are getting hold of it. I am happy that you people are understanding what I am trying. So this is tan 0 to tan pi by 3. Nothing but you can just solve it. It will become 0 to root 3. Yes, so this is the answer we are looking for. Okay, now let's take another problem on range. It says you have to find the range of this logarithmic function, right? So how does logarithmic function works? We have just understood that for logarithmic function, right, it is log 3 with some input here. You just understand it this way, right? This is some input here, right? And we know that the diagram of log is something like this, right? Okay, and this is an increasing function. We know that this is an increasing function. So you just need to now find the minimum value and the maximum value of this function. So here this time around the input is a quadratic function. So what is the input? Input is minus x square plus 4x plus 5, right? This is the function. Or in fact, if I take fx is equal to, this becomes what? Minus x square plus 4x plus 5. So you need to find the minimum and maximum value of this. Now the question is converted to find minimum and maximum value of this quadratic function. So can you easily tell me what it could be? So for quadratic, if I take minus common, this becomes x square minus 4x minus 5. And or in fact, let's say if I am solving for this particular stuff, minus ax square plus bx plus c. So how do you solve this? Or let's say if I take plus only. So you know that if a is greater than 0, it's a upward parabola, and when a is less than 0, then it's a downward parabola. Just revise the quadratic class. Okay, so here you will get the minimum value, here you will get the, here in case minimum, and in this case you will get the maximum value. Here the range would be what? Y min to infinity, right? And here the answer would be from what? mind the brackets, it will be a round bracket. So here it would be from minus infinity to y max. And what is y max? Yes, so y max was nothing but your minus d by 4a, right? So if you just directly apply this particular property to this function, so your function is nothing but minus x square plus 4x plus 5. So which particular diagram it will correspond to? This particular diagram, because your a is less than 0, right? Your a is less than 0, a's value is minus 1. Figure out, that means you will have y max. So what will be y max? So y max will be minus d by 4a. D is nothing but the discriminant. Solve the discriminant. Discriminant was what? D is b square minus 4ac. So if you solve d will come out to be 36, right? So what is the value that we can obtain here is minus 36 by minus 4. This comes out to be 9. So y max actually you will get is 9. So what is the range of the quadratic? So for range of quadratic is nothing but belonging from minus infinity to 9. But we were not asked the range of the quadratic. We were asked the question when quadratic is inside the log. Now tell us me about something about log. Can log take a negative input? Log always takes what? Positive input, right? So now this is now working as a composite system. What composite system it is? Let me draw the diagram. So first of all, you have a quadratic machine, the answer of which goes inside the log machine, and then you get your final answer, right? This is how it is working. So now you have found that this quadratic will lie from minus infinity to 9. This becomes the input for this. So the range of the first function now becomes the input of the second function, right? So but we understand that log, agar aap bolte ho that log, you have inputted this in log, log will not see this because it has here negative value. That's the problem. So log will reject the negative values. It will say I only see these values from 0 to 9, right? So the input of log in this particular question is nothing but from 0 to 9. And when the input is from 0, so for this is 0, and let's say somewhere here it is 9, right? So what will be the value at log 0? Almost log 0, it is minus infinity. If you are going closer and closer to 0, what value you will obtain again? Minus infinity. So the answer to this problem will be minus infinity to log 9 with base 3. And we know that the answer to this particular stuff is yes, absolutely. The answer is minus infinity to 2. This is the range of this particular problem, and this is how you solve this. Now let us take another problem to end the range concept. It says that first of all, these are your GIF functions, right? These are all GIF which are written. So at the first, it looks like a very, very difficult problem to you people, right? You think that it is one of the most difficult problems that you people have seen. But believe me, this is oral. You can do it orally. This is that simple. Let me show you how. So let's go inside this first. So it says GIF x minus 1, and this is in the denominator also, right? It is in the denominator. So it will not be equal to 0. So for this not to be equal to 0, that means x minus 1 should not lie between 0 to 1. So if I talk about the domain, so domain is this particular value for this question. So this is that x will work for every value of r except when it lies between 1 to 2, right? So this is the domain of this particular problem. If domain was being asked, right? Now let us see the oral part of it, how you will find the range. So you have here x minus 1 inside the GIF. What does the GIF does? It returns integer values, everything will, whatever this value will take, it will return integer value. So for example, it will not return 0, but it will return something of, let's say, minus 2, minus 1 on the negative side. On the positive side, it will return 1, 2, 3 and so on, right? These all type of values it could return, right? Now you want to take the, again, the denominator of this. This is in the denominator and you will reciprocal this. Okay, just see to this what will happen. 1 by 2, 1 by 3, 1 by 4, 1 by 5. If I talk about that, this is only positive, right? These are all fractions, right? And if you take the GIF in front of them, this will return you 0. This will also return you 0. This will also return you 0. So if x minus 1 is returning positive values, 1 upon x minus 1 GIF and the whole GIF will return you value. Very simple. The answer is 0 then. Let's talk about the negative fractions. So negative fraction would somewhere look like this: minus 1, right? Minus 1 by 2, minus 1 by 3, minus 1 by 4, and so on. What will be the answers to this? This is nothing but minus 1. Minus 1 by 2, minus 0.5. The answer is yes, minus 1. Minus 1 by 3, answer is again minus 1. Minus 1. All the answers for the negative part are coming to be minus 1. So what should be the answer to this particular problem? So the answer should be, it is only taking, so the answer, that is range of this particular function should only belong two values, minus 1 and 0. But this is the wrong answer. Why? We have still missed one component. What if this particular value becomes 1, right? We know that this will become 1 at 2. So if we take the reciprocal, so this becomes 1 upon this will equal to 1, and the GIF of this will also be equal to 1. So that means it can also return you answer 1. So the final answer to this particular problem is the range of this function is nothing but three values: minus 1, 0, 1. This is the answer we are looking for. I hope this problem is clear now. Now the next concept that we people have to do is the periodicity concept. So what do you mean by periodicity? So let's say if there is a function y is equal to fx, right? Okay, and you say that by changing the input from x to x plus t, your answer again becomes fx, right? And you need the smallest such value of t. So the smallest such value of t, smallest value of t will then become its period, right? So this is how you find period of a particular function. So for example, if I have to explain it with a very basic diagram, sine x. So sine x repeats itself at 2 pi, at 4 pi, at 6 pi, in all these intervals. Why I am saying repeating? So if you say sine 2 pi plus x, it will be nothing but sine x. Similarly, somebody could have said that sir, sine would repeat itself after 4 pi. So sine 4 pi plus x will also return you sine x. But what is the smallest value after which it starts repeating itself, right? So that is 2 pi. So that is why we say the period of sine x is 2 pi. Okay. Also, if you know that the period of, now there are some formulas which you people have to remember. So if you know that the period of a function is t, right, and you change the input from x to ax plus b. Now what I have done here is that I have changed. So for fx, the period was p, and now for you have changed it as ax plus minus b, then the answer would become p divided by mod of a. So whatever is the coefficient of x, it will come in the denominator for the period. This is how you calculate. We'll apply this in the formulas, don't worry, this formula in the questions. Also, if you are given addition or subtraction of two functions, so for example, there is a function f and it is being added or subtracted with a function g, you say the period of this one is t1 and the period of this is t2, then the net period of the total function will be nothing but LCM of t1 and t2, right? And if this net function that you obtain becomes even, right, I'll also explain what is even, then the answer is 1 upon LCM of these two. Okay, don't worry, we'll just do it in the questions. I'm just revising the concepts for you people. So how do you, if we also want to talk about how do you find LCM of a by b, c by d, and e by f, please remember the formula. So LCM of fractions is LCM of the numerators divided by HCF of denominators. So how you people can understand it is, remember like this: LCM of numerators divided by HCF of denominators, right? This is how you people have to remember this property. Let's try and build up this in particular questions. Okay, before going further, let's also understand some formulas which you people have to remember. So these are all the results, but you will try and remember them as formulas. Very important stuff, right? Add them to your formulas list. So what are the formulas? Let's talk about them. So we know that sine x, cos x, secant x and cosecant x are periodic with function 2 pi. Tan and cot are periodic with pi. And if you take modulus of all the trigonometric functions, right, straight away they are periodic with function pi, right? Now you want something when there is a power raised to the trigonometric functions, right? And we are talking about these four functions now, remember. Okay. So sine, cos, secant and cosecant are periodic with period 2 pi if n is odd. If n is even, then the period reduces by half, then it becomes pi. So what do I mean by this is, if somebody asks you that what is the period of sine square x, the answer is straight away pi. Don't worry about it. If somebody asks you what is the period of sine raised to the power 4, answer is again pi. Even if somebody asks you what is the period of sine raised to the power 100, answer is pi. And similarly, if somebody asks you what is the period of sine cube x, you know the answer is 2 pi. Don't worry about it. Just remember this stuff. Okay. Similarly, for cos square x, the answer would be pi. For cos cube x, the answer would be 2 pi. This is what I meant by this particular property. And irrespective of for tan and cot, so we already knew that tan x and cot x had their period as pi. So if you even raise their power by n, right, cot n and tan, the answer will still remain pi. Don't worry about them. So whether n is odd or even. Now let's apply all these things that we have just garnered in the particular problems. Okay, so the first problem here is that it says you need to find the period of fx is equal to sine of sine x by 5, right? So don't worry about this particular stuff. If this is getting repeated, outermost function will automatically get repeated. Let's say this is the outer function, this is the inner function. So if the inner value is repeating, what the outer can do, it will automatically repeat on the values based on the inner function. So the inner function here is sine of x by 5. So what is the period of sine of x by 5? So what will be the period of sine of x by 5? So the period of sine x is 2 pi. So for sine x by 5, the period will now then will become what? Not 2 pi by 5, it will be 2 pi 1 by 5. Remember, we did the formula that if sine ax is there, then the period will become 2 pi by modulus a. So here the role of a is being played by 1 by 5. So this actually comes out to be 10 pi. So that means this inner function repeats itself after a period of 10 pi, and that is the particular answer. So the answer to this problem is nothing but 10 pi only. Okay. Let's solve the other problem. You need to find the period of now sum of two functions. Tell me first of all the period of this first one, t1. Let's say if I call the period. So it will be 2 pi divided by the coefficient of x, which is 2 pi by 3, which only becomes what? 3. Similarly, solve this one. So this becomes t2. What is the period? This becomes 2 pi by 2. What will be the value then finally? It will be 4. So t1 is having period 3 and the next function has having the period 4. So what is the net period? Net period then will become the LCM of is nothing but LCM of 3 and 4. What is the LCM of 3 and 4? 12. So the answer to this problem is that the period is 12. Okay. Let's apply this again in the third problem. So for third problem, you should not get bothered about this 5 and this 7. They are not required in the period stage. Okay, so for this particular stuff, the period of this function is 2 pi by 3, right? And for this t2, it is 2 pi by 8. Now you want the period of the net function, so we will say LCM of t1 and t2, or in fact I will say LCM of 2 pi by 3 and 2 pi by 8. How do you find LCM of fractions is take LCM of numerators. So LCM of numerators is LCM of 2 pi and 2 pi, and divide them by HCF of denominators, that is 3 and 8. So the LCM of 2 pi and 2 pi is nothing but 2 pi. What is HCF of 3 and 8 is 1. So the answer to this particular problem is nothing but 2 pi. 2 pi is the period. Okay. So next is sine raised to power 4 and cos raised to power 4. So we know that the period of this particular function is, tell me, yeah. So 4, that is even power has, yes, pi. For this also you have T2 is equal to pi. And if you say that you need to find the LCM of these two, net answer would have been the LCM of T1 and T2. So you should have said answer is pi, but this is the wrong answer. Remember, the answer is not pi here. So I highlighted a particular formula here. I'll just go back. Yes, in this particular slide I highlighted if hx is an even function, that is this complete function is even, then the answer is half times LCM of T1 and T2. So now let me show you how we apply this here. So first of all, how do you figure out it is an even function? If I replace minus x in place of by x, and f of minus x is equal to fx, right? So this implies it's a even function, right? So which is very much true here. If you see that if you replace minus x here, no problems, it will still remain sine whole raised to power 4. It will still remain cos 4. Why? Because see, it's even, power is even. So this is an even function altogether. So it says T1 is equal to pi, T2 is equal to pi. Answer should have been, period should have been what? Pi. But since it is an even function, what we will say, the answer is not pi, answer is pi by 2. So the answer to this is nothing but pi by 2. In fact, it's a very famous problem. You can even remember the answer to this particular question. Now similarly, let's see apply this in this. So first of all, tell me, if I put x instead of x, I put minus x, so what this will become? So it will be something of minus sine x, because sine of minus x is minus sine x, and this will become cos of minus x is nothing but cos x. And if you see, this will again return you the same function. So that means this is an even function, because you still are getting, by replacing minus x, you are still getting fx. So that implies fx is even, right? So now tell me about first cos of sine x. So what is the period of this function? This period is 2 pi, because it will depend on the innermost function. Other function that you are having is cos of cos x. The period of this is again 2 pi. LCM of these two should have been 2 pi, but the answer would be, since it is an even function, we'll divide it by 2. Answer is pi. This is the period of this particular function. The same thing you people can apply it here also. So if you replace x by minus x, so I am taking all these standard problems because they are very famous. So right, if you write something of this plus modulus of cos of minus x, cos of minus x we anyway know is nothing but cos x, so it doesn't matter. And since it is mod, so this minus will be obtained, or you can say this minus will be replaced instead by the modulus sign only. And again, if we see, this is fx, so that implies fx is here also even, fx is equal to even function, right? So again, what is mod sin x period? We just did in the formula. If we replace mod, then the period will be halved. What is the stuff for this? This will also have period pi. LCM is pi, no doubt about it, but the answer is not pi, answer is pi by 2, since it is a even function. Okay, this is how you apply that important concept in these kind of problems. Remember all these three problems, these are very famous. Let's take the last two problems also on periodicity. So it says the first one is cos of x by 2 and sine of x by 2. Okay, if you try and do this by the even odd property that we did, fx we know is an even function. Why an even function? Can you tell me? Yes, because if you replace x by minus x, you will still get the value as fx. I know this point. Okay. So what is the, you can say, what is the period of this? Can you tell me? Yes, the period of this would be, now how do you calculate this? So we know that the period of cos x, modulus cos x is pi. Now instead of x, your input is x by 2, so it will become x upon 1 by 2. So the answer then becomes 2 pi. So the period of this is nothing but 2 pi. Now what about modulus sin x? Modulus sin x has period pi. So now you have two answers, 2 pi and pi. So their LCM is 2 pi, right? But since this is an even function, so what you people will generally do, you will say, sir, the answer is not 2 pi, but the answer is pi. You will halve this answer, right? But see here, this answer is wrong. This is not the answer. Answer is still 2 pi, the LCM only. Right? Why? Because this even function property, right, was valid when you have something of hx is equal to fx plus gx. That means when this function has input x and this function also has input x, whereas in this particular case, if I talk about, it is having x by 2 here, right, and the other function is having input only sin x. This has x by 2 as the input and this has x as the input. We will not apply this property here. This is just the way of explaining that why it will not work. I am not getting into the proof of this particular portion, right? I can show you that why it will not work, but that's out of the scope of this particular lecture. So the answer for these kind of problems, you will not half, you will just answer the LCM. This is the answer. Okay, let's take another problem to understand this particular part. So this particular part, this, right, this is called the fractional part of x. This is the fractional part, and the fractional part is basically periodic. So this is the graph of the fractional part of x. That is, this is the answer, right? Here. So if you see, from 0 to 1 portion gets start repeating itself again and again. You just start moving this bar. So, and if you move this bar back here, if you move this bar back here, so the pattern is getting repeated, and it is getting repeated at a distance of 1. So if I talk about the periodicity of GIF x function, it is 1. So that means it repeats itself after 1 units. So now let us see what is there in the power of this particular answer. So it says sine 3 pi GIF x plus tan pi. This is GIF x and this is fractional part x. So we also know that GIF, please remember this, GIF is not periodic first of all, right? It is not a periodic function, and if there is a non-periodic function, so that means this should become non-periodic. Why? Because this b component, the added component, is non-periodic, so this should become non-periodic. So answer option, you will find that there will be a D option for this question, that is says non-periodic, right? And very quickly people will mark this, but this is not the answer, right? So what is the problem here? Let us then highlight that. So here you have tan pi x, right? So now here you have tan pi GIF x. We know that GIF takes only, it will only return integer values, right? It will return you what? Integer values. So I can say it is tan pi n, where n belongs to set of integers. And what is tan n pi? We know that tan n pi is nothing but always 0. So actually this component is not there in the power. So what is your net power? It is actually only this component. So this question is very important because at the front it looks like the answer is non-periodic. Why? Because this function is periodic but this is not periodic. So if you have a component which is non-periodic, this will make the entire question non-periodic, but this is not there. So the entire question is actually e raised to power sine 3x into fractional part x. This is the answer. Okay, and how do we solve this? How do we solve this? Sorry, not 3x, this is 3 pi, right? Otherwise this cannot be solved. Okay, so 3 pi. How will you solve this now? So the period of 3 pi fractional part x is only dependent on fractional part of x. This is periodic with period 1. So that means the period of this entire thing will be nothing but t becomes 1. That means it will repeat itself after an interval of 1 units. This is the answer we are looking for. And this is how you solve difficult questions based on the period. Alright students, students will be doing the today's lecture will be ending it here itself. We intended to do the odd even and the identical function component also in this particular lecture as mentioned in the syllabus. Don't worry, we'll start from odd even and the identical part from tomorrow's lecture, and then maybe probably we end this chapter tomorrow itself. Okay, re-revise these videos again and again for today's lecture so that you are comfortable with the domain and range part. Right, these are the most important crucial components of the calculus in your class 12 syllabus. Good night, see you tomorrow.